Hi learners, welcome to my video lecture. Today we will discuss power system analysis subject. The subject having 2017 graduation 5th semester triple students. So power system analysis. Okay. So what is power system? Before going to enter the subject, you must know the aim to study of power system, aim to study of that subject. Okay. So the subject is power system. What is aim to study the power system? That is most important. Okay. So what is aim to become familiar with different aspects of power system component and modeling. So that means you familiar with different aspects of power system component. That only you can able to design a new power system. In case you understand the full concept of power system analysis means you can able to design a new power system, that is aim to study power system. That is very important. So this is the overview of power system. So the power system, so that is aim to learn power system studies. What is it? Already I told you. So that is to become familiar with different aspects of power system component and modeling a power system. This one is outcome. What is outcome of power system is nothing but outcome is nothing but you can easily designing a new power system. That is outcome. What is outcome of power system? You thorough that particular subject means you can easily able to design a new power system. So that is called as a outcome. Okay. So you know aim and outcome of subject. So now what is power system? That is another question. You ask yourself question why you are going to study that particular subject. Okay. Then what are all the things involved in that particular subject? So the before that subject, what is power system? So how to represent the power system? How we represent the power system? What is power system? You know, you can travel the you can travel bus means you can see the power system, transmission and the distribution. Okay, that is the power system, the generation to the distribution called as a power system. From the generator to the distribution side, that is called as a power system. Simply we can say how we will represent the power system. That is the concept. So how to represent the power system? A typical power system consists of three-phase grid. A typical power system consists of three-phase grid, which are substation is transmitted to the distribution transformer and distribution transformer fed to the various load. That is representation of power system. You can understand. So once again I am repeating you how representation of power system. What is power system? So a typical power system consists of three-phase grid, which are generating station. You know the generating station like the Metur, Neyveli, these are the generating station is transmitted to the distribution transformer that is nearby your city. That is the distribution transformer. That particular distribution transformer is transmitted to the distribution transformer. What is distribution transformer? The distribution transformer is nearby your house. Okay, nearby house is called as a distribution transformer. That particular distribution transformer fed to the various load. Our house is load. So this is the representation of power system. So that is called as a generation, transmission and distribution. That is why we are representing the power system. Are you clear? Okay. Next, what are the component of power system? That is also important. What are the components? These are the very simple question. What are the component of power system? Generator, motor, transformer, distribution transformer, loads. These are the component of power system. Simple. What are the component? You can see that every electrical component, that is the component of power system. Here high power applications, not for low power application. Low power applications are power electronics. Okay, high power applications are power system. So the power system component: generator, motor, transformer, distribution transformer, power transformer, heating coils, lights, loads, etc. These are the component of power system. Are you clear? So once again I am telling you what is the aim to study the power system, to become familiar with different aspects of power system component, that is study of aim of power system, what is the outcome, you can understand the concept of power system entirely means that is the outcome. You can able to designing a new power system, that is generation to the distribution side. You can easily create an erection of power system, that is important. Power system is very important for electrical engineering student. Okay, so then we discussed what is power system. Power system is three-phase grid, which are generating station feed energy from which are substation tap energy. The tap energy is transmitted to the distribution transformer, and distribution transformer fed energy to various load. That is called as a representation of power system. Then component of power system. What are the component? Under all the component you can see the power system. That is the component of power system: generator, transformer, transmission line, distribution transformer, insulator. These are the component of power system. Okay. So this is the single line diagram, very important single line diagram. I already said generator to the distribution side. You can see the single line diagram, generator to the distribution side. So generator to distribution side, here they mention generator to distribution side. So single line diagram, what is single line diagram? Because simply I said Neyveli is a generating unit. Okay. Here the Coimbatore is a one load unit. Okay, so generator to generation station from Neyveli to Coimbatore or Neyveli to Bangalore, it will transmit the power. How? So this is the Neyveli. You can assume this one generator is Neyveli, means that the consumer is Coimbatore or somewhere else. Okay, the Coimbatore or Bangalore somewhere else. So what are the processes are involved in that particular generator to the distribution side? That is the layout. You can imagine n number of kilometers, 1000 kilometers, 500 kilometers is possible, because here the high voltage transmission system also we are implemented, high voltage transmission. Okay, so here the generator is Neyveli, means the distribution side is Bangalore or somewhere else. Okay, that is called as a distribution side. Okay, generator. So here generator, here how it will be represented, single line diagram. So this is the pictorial representation. Representation. The components are represented by the standard symbol. You can see the component generator. This is the generator. Components are represented by the standard symbol. Simply circle, and instead of this symbol is called as a generator symbol. So each and every component having the standard symbols. Okay, so generator like this. This one is transformer. This one is transformer. This one is transmission line. J50 ohm is a transmission line. This one is transformer 2. This one is transformer 3. This one is transformer 4. Then consumer. So what are the process? The generator, already I said the representation of power system. Okay, so generator is transmitted to the distribution transformer fed to the various load. So each, what is single line diagram? The single line diagram is nothing but the pictorial representation of power system. The components are represented by the standard symbols, and the interconnections are shown by straight line. The interconnections are shown by straight lines. The important thing is, beside the symbol, the rating are also marked on the single line diagram. Beside the symbol, you can see the symbol. Beside the symbol, the rating are also marked on the single line diagram. For example, generator having the 3 rating. One is 100 MVA, 11 kV, and 10% reactance. So you can see the generator, all the component rating. You can see the transformer 1, 11 bar 132 kV. Okay, so 100 MVA. What is MVA? Megavolt ampere. That is power rating. Okay, and kV, kilovolt, 11 kV generator. That is 10% reactance. So this is the reactance. 100 MVA, 11 kV, 10% reactance. Here the transformer 1 11 bar 132 kV. The key point is the, and also transformer 50 MVA 8% reactance. Here the primary transmission. So the key point is the generator is always connected with this step-up transformer. So the navally generation is, you assume that this one is navally or May2, okay, or Kalpakam. Any generating unit you can assume. Here 11 kV generation, you can see here 11 bar 132 kV. So 11 bar 132 kV with the help of step-up transformer. This one is step-up transformer. This one is step-up transformer is step up by 11 bar 132 kV. Here 11 kV we step up by the 132 kV with the help of step-up transformer. Here the transmission 132 kV transmitted to the that particular receiving station. So that particular distribution transformer. Here 132 kV received and step down by the 33 kV. Are you clear? Step down by the 33 kV. So again the 33 kV transmitted to this particular transmission system line. Here the 33 kV, here the 33 kV is received and again converted into the 11 kV. Here we generated 11 kV. Here also we finally receive 11 kV. So due to the lossless transmission system, we can step up by the 11 bar 132 kV. Again we receive 11 kV. This one is nearby your house. Nearby 11 kV received by the consumer. 450 volt. That is 3 phase. Consumer will utilize the power. Or is a single phase 230 or 240 volt. 3 phase 415 volt. So here is a 3 phase system. Finally consumer receives 415 volt. So this is the concept. Once again I am telling you what is single line diagram. The single line diagram is a pictorial representation of power system. The components are represented by the standard symbols and the interconnections are shown by straight line. Beside the symbol, the rating are also marked on the single line diagram. That is called as a single line diagram. You can understand the single line diagram fully clear means can solve any kind of problem. So the key point is the single line diagram, the generator is always connected with the step-up transformer. The receiving end, that receiving side is step-down transformer. Okay. Next, per unit representation. So what is per unit? So before going to per unit representation, what is aim? What is aim of per unit representation? Aim to learn. Every time I tell about what is aim. Any topic, any particular heading you can learn means why you are going to study that particular topic. So what is aim? What is per unit? What is aim to learn? So what is per unit representation? In previous slide, single line diagram. Single line diagram you can see the rating of the component. What are the rating of the component? We can see MVA rating and kV rating and reactances value. So these three values are major key point. In for example, transformer means transformer primary and secondary voltage kV value. You know, okay. So now the per unit representation is nothing but because of the values of power system is too larger. MVA, kilovolt ampere, kVA, megavolt ampere, kV, thousands values. So the complications, the values of complication, the 1 0 is missing means the entire power system is collapsed. So we go for the per unit representation, for the mathematical representation. For the calculation purpose, we go for the per unit representation. So what is aim? What is per unit? So the per unit is nothing but the ratio of actual value to the base value. So actual means what are the values specified in the single line diagram. Okay, previously we discussed the single line diagram. That single line diagram, what are the values specified in the single line diagram? That is actual value. What is base value? We can assume the base value or specify the base value. We can choose that particular base value, that is called as a base value. That simply we say, in case we solve the problem, we can easily understand the concept. Okay, what is per unit representation? The per unit representation, the ratio of actual value, because of mathematical representation, we calculate the single line diagram and simulate the single line diagram. We go for the per unit representation. The per unit representation, the ratio of actual value to the base value. The actual value is nothing but what are the values specified in the single line diagram, that is actual value. The base value, you can choose the base value. One of the generator rating or the questions also specify the base value. You can choose that particular base value to find out the new per unit reactance value. That is called as a per unit representation. So the per unit is nothing but actual value divided by base value. Okay. In case of percentage of per unit is nothing but percentage of per unit nothing but into 100. Okay. So what is outcome of per unit? That is advantage of per unit. That is also important. That is I already said. So the chance of confusion between line and phase quantities. In case we go for the per unit means the confusions of line and phase quantities is minimized. So and also the per unit quantities, that value either side of the single phase transformer is same. Okay. And the same time either side of the three phase transformer also same, regardless star to star, star to delta, delta to delta star transformer. So that is the concept. And one more advantage. So the per unit value always unity or less. The value, per unit value, that is very very important. Per unit value always unity. Unity is nothing but 1. Per unit value unity or less than, that means 0.0001 or 0.1 or 1. So value is unity or less. Usually the per unit value unity or less. Okay. So that means the mathematical computation is very very easy. The computer calculation also easy. The simulation process also very easy. That is why we go for the per unit value. And you understand. So that means the number, the values, MVA, KVA, all the values we are going to convert it into the unity or less. That means 1 lakh. In case you got the value of 1 lakh means that particular value also you have to convert it into unity or less. That is the advantage. You can keep it on mind. So in case you got the answer, you get the answer for 3, 4 per unit means it is wrong. The per unit value, the calculated value always, the value is 1 or less than 1. Okay, the find out value. That is the key point. Okay, another key point. So already I explained previous slide. Per unit percent. The ratio of actual value to the base value is called as a per unit system. The advantages. What are the advantages? Manufacturer, the one more point I missed. The manufacturer usually specifies the impedance or reactances value. So you can see the nameplate detail. When you go for the substation or nearby substation, you can see the values, the parameter values specified in the per unit only, not for MVA and KVA. The per unit referred either side of single phase transformer is same. Already I explained. Okay, a chance of confusion between line and phase quantities. Line and phase. The confusion is minimized. Then the computational effort, that is a mathematical calculation, computational effort of our system very much is reduced. Okay, usually per unit quantity being the order of unity or less can be easily handled with the computer manual calculation. Okay. Next, per unit representation for single phase system and three phase system. Both are same. Per unit representation of single phase system, per unit representation of three phase system, both are same. For how same means the three phase system have to calculate for the per phase base analysis. Per phase. Okay. So per unit representation of single phase system, how to calculate the impedance value? The per unit impedance equal to actual impedance and base impedance. What is actual? Already I said. What are the values specified in the single line diagram? That is called as a actual value. The base value, what is the new value or the new parameter value specified? That is called as a base value. So the per unit impedance is equal to actual impedance divided by base impedance. Okay, how calculate the new value of reactance? So what is reactance? What is impedance? You know first. Already you are prerequisite knowledge, the transmission distribution already you studied. The power system analysis prerequisite knowledge is transmission distribution. You know already you know the impedance and reactances value. What is impedance? Impedance is nothing but Z. Impedance is nothing but Z. Impedance is nothing but Z is equal to R plus Z is equal to R plus JX. That is impedance. Resistance plus reactance. What is reactance? That is X. So the resistance is negligible small. The part is 0 means only X only present. That is why X are impedance or reactance. In case resistance is present in the transmission system is, that is the impedance. Only the resistance value is negligible or 0 means only the reactance value is present. Okay. So the reactance. Here also impedance per unit, Z per unit nu also same. Z per unit nu is equal to also same. So X per unit nu is equal to X per unit volt into kV base volt divided by kV base nu into MVA base nu divided by MVA base volt. So this is the very important formula to calculate to find out the new per unit reactances value. So the transmission system, before you can see the single line diagram, previously you can see the single line diagram from the generation to the distribution side, MVA rating, all the MVA, all the power rating is common. In case of power rating is common, it is not common value means the power system is not reliable. So you can go for the all the power rating in the common MVA base. So this is the formula we can choose is the common MVA, converted into the common MVA base. So X per unit nu is equal to X per unit volt into kV base volt divided by kV base nu into MVA base nu divided by MVA base volt. Okay. So this is very important formula. Keep it on mind. Okay. So up to this we discussed what are the power system, how representation of power system, single line diagram, and per unit representation. So these three topics we covered today video lecture. Next video lecture we will discuss how to solve the per unit representation problem and unit number 2 overview. Thank you.